Namaste everyone. In this video we shall learn about an electrical component called thermistor. We shall learn about thermistor by answering a question. I have selected this question from an IGCSE Physics extended question paper of June 2021. Let's see what the question says and let's learn about thermistor as well. So let me select the question first. You can see here there is a question, and in this question a student sets up a circuit that includes a 12 volt battery. I'm just reading out the question for you. An 800 ohm resistor, a voltmeter and thermistor as shown in figure 8.1. This figure is an incomplete circuit diagram because there is nothing that is present between P and Q. There the student has an intention to place thermistor. Probably he doesn't know the circuit symbol of thermistor, and that's why he's unable to complete the circuit diagram. Now let's see what is question A. Complete figure 8.1 by drawing the symbol for a thermistor between terminals P and Q. So let's see first how to draw the circuit symbol of thermistor, and then we shall draw it in the circuit diagram. A thermistor can be drawn like this. This is the standard circuit symbol of thermistor. This is the circuit symbol of thermistor. We need to introduce this circuit symbol in the circuit diagram, where between the terminals P and Q. So let's draw here. I'm drawing the circuit symbol of thermistor between P and Q. So in this way we can complete figure 8.1, and we have answered question 1, which is for 1 mark. Question A, which is for 1 mark. Now question B is about 12 volt battery, and he says this 12 volt battery consists of 8 identical cells. 8 identical cells. You can see here the keyword is identical, connected in series. Calculate the electromotive force. Calculate the electromotive force of each cell. In short, electromotive force is EMF of each cell. EMF or electromotive force is similar to potential difference in the sense that it has the same unit, that is volts. But there are certain differences between electromotive force and the potential difference or voltage. But however, calculation is concerned, as far as calculation is concerned, and the calculation part remains same. How we calculate potential difference, in a similar way we can calculate the EMF of cell. So now let's see how to calculate EMF of each cell. So whenever we connect two or more cells in series, we can use this formula. So V is equal to V1 plus V2, so on up to Vn. So if this formula is valid when n number of cells are connected in series. So what does V represent here? V represents the EMF of the battery, whereas V1, V2 up to Vn represent the EMFs of the cells connected in series. Here, because the cells are identical cells, we can say V1, V2 and V are all equal to one another. And what is the value of V? As I said, V is the potential difference of the battery or the EMF of the battery. It is 12 volts. Now because V1, V2 and Vn, they are the EMFs of identical cells. They will be equal to one another. So I can write x plus x, so on. How many x should I write here? I should write 8 number of x here. So why 8 number of x, and what does x represent? 8x because there are 8 cells in series, and x is the EMF of each cell. So like this, if we calculate further, so 12 will be equal to, x is added 8 times, so 12 is equal to 8x. 12 is equal to 8x. Now, so x will be equal to 12 by 8. X is equal to 12 by 8. So if you solve this, so you will get it as 1.5 volts. 5 volts, as I told before, the SI unit of EMF is same as the SI unit of voltage or potential difference. So we have answered this question B, wherein they have asked us to calculate the EMF of each cell in series. So what is the answer? The answer is 1.5 volts. So let's write that answer in the space provided. So here, so what is the answer? The answer is 1.5 volts. Okay. Now let's look at the next question. The reading on the voltmeter is 8 volts. If you observe the circuit diagram, voltmeter reads potential difference across thermistor connected between the ends P and Q. So that means 8 volts potential difference is present across thermistor PQ. Now we need to determine the resistance of the thermistor. So we know the potential difference across the thermistor, which is 8 volts. So I'll write 8 volts here. This is 8 volts. And we need to know the resistance of the thermistor. See, it will be possible for us to determine the resistance of the thermistor if you know the current through the thermistor. We do not know the current, we do not know the resistance of the thermistor. So how do we find the resistance of the thermistor? First, let's find out what is the current through the thermistor. For that, if you observe the circuit diagram carefully, this 12 volts of the battery, out of 12 volts provided by the battery, 8 volts is appearing across the thermistor remaining. So 12 minus 8, 4 volts is across the 800 ohm resistor. Now let's first find out what is the current through the 800 ohm resistor. Now how does this help us in knowing the current through the thermistor? Let's see this first. So let me mark the current here. Let's say a current of I amperes is drawn from the battery. So this current will flow through this 800 ohm resistor, and at this node the current has two paths to flow. One is through the voltmeter, another one is through the thermistor. An important point that must be remembered here by all of us is the voltmeter is designed in such a way that its resistance is very high. Because the resistance of the voltmeter is very high, negligible current flows through the voltmeter. Ideally, zero current should flow through the voltmeter. Practically, negligible current flows through the voltmeter. That means almost all the current that is flowing through 800 ohm resistor, that is I amperes, will flow through the thermistor. So let me mark I here. I hope it is clear why current I is flowing through the thermistor. So very negligible amount of current will flow through the voltmeter as its resistance is very high. We know that for a given potential difference, uh, current is inversely proportional to resistance. If resistance is very high, current will be very less. Now let's calculate the current through the 800 ohm resistor. So we know the value of V, which is 4 volts, and we know the value of R, that is 800 ohms. We need to find out what is the value of I here. For that, let's use Ohm's law. So Ohm's law says I is equal to V by R. I is equal to V by R. So now I is equal to V is 4 divided by R value is 800. It is the resistance of the resistor. Now if you simplify this, you will be getting it as 1 by 200 amperes. We will get the current through the 800 ohm resistor as 1 by 200 amperes. Now the same current, that is 1 by 200 amperes, will flow through the thermistor as well. So now we know the current through the thermistor, that is 1 by 200 amperes. We know the potential difference across the thermistor, which is 8 volts. We need to find the resistance of the thermistor. So again, using the formula, V is equal to IR, or R is equal to V by I. So what does R represent here? R here represents the resistance of the thermistor. Now what is the value of V across thermistor? It is 8 volts divided by value of I. I is 1 by 200. 1 by 200. So now this can be written as R is equal to, this 200 will get multiplied with 8, so it becomes 8 into 200. So 8 into 200 is 1600 ohms. So what is the resistance of the thermistor? Resistance of the thermistor is 1600 ohms. So now we can write this answer here in the space provided. Determine the resistance of the thermistor. So it is 1600 ohms, or 1.6 kilo ohms. So this is the answer. So let me rewrite this properly. So it is 1600 ohms. So if you get this value showing all the steps, you will be awarded with 3 marks. Okay. Now let's see the last sub question, and that is second sub question. So a few hours later, the student notices that the reading on the voltmeter is greater. Explain what can be deduced from this observation. So let's understand the question first. So a few hours later, so if it says the reading of the volt, or reading on the voltmeter is greater. Reading on the voltmeter is greater. That means it is 8 volts initially at the beginning of the experiment, but after few hours it means the voltmeter is showing a reading more than 8 volts. So that means what can be understood? First of all, we can understand that the potential difference or voltage across thermistor, voltage across thermistor has increased. The voltage across the thermistor has increased. Now why has it increased is the next question here. Now let's see this. See, whenever we connect two or more electrical components in series, here 800 ohm resistor and thermistor are the electrical components connected in series, you can say that the potential difference will be more if the resistance is more. how can we say that? If the components are connected in series, same current flows through both the components or devices. So same current flows, and so V is equal to IR. So V will be greater if the value of R is greater. Now initially the difference potential difference across the thermistor was 8 volts. Now it has increased. Remember, it has increased. Now as same current flows through 800 ohm resistor and the thermistor, means that potential difference has increased implies that resistance of the thermistor has increased. I told that a resistance of the thermistor will depend on temperature. So now what is one more thing that can be deduced from this observation? So we can say that R R of thermistor, let me reduce the size, R of thermistor has increased, has increased. I'm writing increased here. So that's the second thing that can be deduced. Voltage across the thermistor has increased. Fine. That's what. Why is it so? Because the voltmeter reads the potential difference across the thermistor. R of thermistor has increased. Now, can we say anything about temperature of the thermistor? What has happened to the temperature of the thermistor? As I told at the beginning of this explanation of this video, the resistance of a thermistor depends on temperature. How does it depend on temperature is the question here. So resistance of a thermistor uh, sometimes is directly proportional to temperature or inversely proportional to temperature. So there are two types of thermistors: positive temperature coefficient PTC, positive temperature coefficient PTC type of thermistor, and another type of thermistor is NTC thermistor, so negative temperature coefficient thermistor. In IGCSE, the thermistors that are used in the question are all NTC type of thermistors, meaning negative temperature coefficient negative temperature coefficient thermistor. So in these type of thermistors, resistance is inversely proportional to temperature. Resistance is inversely proportional to temperature. That means resistance will increase when there is a decrease of temperature. So here in this question we can see that the R of thermistor has increased. R of thermistor has increased. We have written that. So what is this indicator? From this, what can we deduce? We can deduce that temperature has decreased. Temperature has decreased. I'll show this symbol to indicate a decrease in temperature. So temperature has decreased. So this question explain what can be deduced from this observation, and you can observe that this question is for 3 marks. So we have written 3 deductions here. One is voltage across the thermistor is increased, first point. R of thermistor has increased, so second point. Temperature of thermistor has decreased. So we have written 3 points for 3 marks. So in this way we have answered all these questions. So I hope you all have understood this. So please subscribe, like and share. Do not forget to subscribe. Please do not forget to share these videos. Let these videos reach many more students and help many more students and help them in their exam preparation. Thank you for watching. Thank you again.